Hey everybody, welcome to CML Online, your CSEC Mathematics expert. And today we want to get into the subtopics and the major topics and the broad topics that's coming in paper 2. And let's get into it. So the first question, or the first topic rather, deals with number theory, consumer arithmetic, and computations. And these are the subtopics here. And this question will illustrate some of these subtopics. So let's read it. Using a calculator or otherwise, calculate the exact value of 1 4/7 plus 2/3 minus 1 5/6. First up, never do the otherwise. All right, so the otherwise is given to give students a fair chance, but chiefly if calculator is mentioned first, do the calculator. And that's a generally good idea for CSEC. Don't do the otherwise. Do what is said first. That is usually the easier option. Okay? So that's a subtle hint for exam techniques, which we will get into later on as well. So in this case, if you're using the calculator, then we're going to try to use a scientific calculator. And specifically, I recommend this calculator here, Sharp DAL EL506TS. All right, and if we can enter this exactly as we see it into this calculator. So it goes like this: 1 ABC 4 ABC 7 plus 2 ABC 3, where these two fractions here are represented by this command line. It's the exact same thing, where ABC is actually the fraction buttons that tells the calculator it's dealing with a fraction. And the ABC button is somewhere around here, okay, in that region of the calculator. So once we have that down, go ahead and let's press the equal sign and tell me if you get this. You guys, you got this result? Great. Most important note, this is not a R. Neither does it mean remainder. This means it's a fraction. And it actually means this, 2 and 5 over 21. Okay, so do not put this as a remainder at all. That's the calculator's way of representing a fraction. Moving on, next after we have the minus sign. Minus sign, then 1, ABC 5, ABC 6. And if you enter it exactly as it is here, you should get, and press the equal sign, you will get 17 over 24. Again, this is not R. Neither does it mean remainder. It means 17 over 42, and the final answer is 17 over 42. Any questions there? Hey guys, awesome. If you got that, good job. If you didn't, well then simply go back into the recording and check your command line again. All right, let's move on. Let's try this question here. Try this question, and when you're ready, you can go ahead and pause the recording. Try this question, and when you're ready, you can go ahead and unpause and see the answer. Hey everybody, I hope you got this answer. It's going to be 18 over 15. And a helpful hint, the numerator should be 13 over 15. All right, so it's 4 marks. So you should present some type of working nonetheless, even though you're using calculator. You work out the top, get 13 over 15, and then divide it by 1 and 5 over 8. And the result should be 8 over 15 to the lowest terms, right? And as well, the calculator gives you the fraction in the lowest terms. So that's one great fallout from that. All right, so next, Let's look at this question here. Write the value of the cube root of 27 over 9 squared as a fraction in its lowest terms. First up, second function, x cubed, takes care of the cube root. So if I want to say cube root of 27 over 9 squared, I'm going to put second function followed by x cubed. And if I want to put the square root, actually there is a square root sign there already. All right. But for the cube root, it's going to be second function followed by the x cubed sign, followed by 2, followed by 7, equals 3. Any questions there? Go ahead and check your calculator and see if you get it. All right, great. Next, press the on button. But before you press the on button, record or write this 3 down somewhere so it's safe. Press the on button, then press 3 ABC, open brackets, 9 x squared, close the brackets. And you should get, with the equal sign, you should get 1 over 27. Again, this is not an R, neither is remainder. So the answer should be 1 over 27. Automatically, with the calculator, every fraction is in its lowest terms. All right, awesome. Let's try this question here, which utilizes some decimal that we have done before. Some decimal work on the calculator. Go ahead and try this, and when pause the recording, try it, and then when you're ready to hear the answer, unpause the recording. Hey guys, the answer should be 2/5 or 0.4. Helpful hint, this part 0.24 divided by 0.15 should be 1.6. All right, good job for those of you who got it. So now we're going to look at significant figures. We're going to look at this number 278.29 and start with the procedure. So we're going to start with the original number, which is 278.29. Then we're going to count the non-zero digits from left to the required amount of significant figures and circle. So before we even understand the amount of required significant figures, let's check how much significant digits we have in, or figures we have in this number. So once it's non-zero, it's going to be 2 is significant, 7 is significant, all these numbers are significant. So we have 1, 2, 3, 4, 5 significant figures, but we only require 2 significant figures. So we're going to start from the left and count 1, 2, circle that number, and then we're going to underline the number to the right of the 7, which is going to be 8. Then ask ourselves, is the number underlined digit above in the 5 or more category? Is 8 in the 5 or more category? If it is yes, we add 1 to the 7 and we have 280. If it's no, 7 remains and the answer will be 270. So go ahead and put it in the comments. Which answer do you think is going to be the correct answer? Is it 280 or is it 270? Hey everybody, hope you all got the right answer. The right answer should be 280 to 2 significant figures. Right, pretty much straightforward. And let's try this question here. You're going to have 2.5 squared minus 2.89 over 17. Give your answer to the correct number of 2 significant figures. All right, so go ahead and pause the recording. Attempt it, and when you're finished, unpause the recording to find the answer. Hey everybody. So the answer should be 6.08. However, to 2 significant figures, it's going to be 6.1. Now, a word of caution, a word of note, 0 in this case is significant. Why? Because it is between two non-zero digits, which is 6 and 8. So we in fact will count the 0 as a significant figure. Surprise, surprise, right? But stuff like this come all the time. So it's going to be 1, 2, two significant figures. Circle the 0, underline the 8. Ask yourself, is the 8 in the 5 or more category? The answer is yes. So we're going to add 1 to the 0, and it becomes 6.1 to two significant figures. Any questions there? All right, great, awesome. Let's look at decimal places. We're going to convert 363.75 to one decimal place. We're going to start with the original number, which is 363.75. Then we're going to look at the first digit after the decimal point, whether it's 0 or non-zero, and that digit is going to be 7. Look to the number to the right of the 7 and ask if it's in the 5 or more category. Is this number in the 5 or more category? If the answer is yes, we add 1 to the 7. If it's no, we leave it as is, and the answer is going to be 363.7. So which is the correct answer, 363.8 or 363.7? Put it in the chat. Hey guys, awesome. So the answer should be 363.8 to 1 dp. All right, let's continue. Let's do this question. We're going to get the answer exactly, and then we're going to get it to 2 decimal places. Go ahead and pause the recording and then unpause when you're ready. Hey guys, so the answer should be 117.126 exactly, but to 2 decimal places, 1, 2, circle the 2, underline the 6. The 6 is in the 5 or more category, so we're going to add 1 to this 2 to make it 3. So 117.13 should be the answer for part 2. Any questions there? Please in the comments. All right, let's continue. Let's look at ratios, because ratios is on the topic for CSEC this year. So it says a total of 1,200 students attend Topview High School. The ratio of teachers to students is 1 to 30. How many teachers are there at the school? Well, let's check it out. Let the number of teachers be X. So X to 1,200 is going to be 1 to 30. Hence, X over 1,200 is going to be equal to 1 over 30. So now we're going to simply just make X the subject. So X is equal to 1 over 30 by 1,200 over 1, which is 40. Place this in the calculator as well, and you will get 40. So the number of teachers to the number of students is going to be represented by the ratio 1 to 30. And if it's 1 to 30, it means this number here, whatever X has to be, it has to be 1/30th of the whatever this is here, right? Or this number here, which is the number of students, should be 30 times how much ever teachers we have. Okay, and it pans out because 1,200 is 30 times 40. Any questions here? Hey everybody, awesome. Let's go on to the next part of the question. That's the answer there again. Let's look at, it says that the 2/5 of the students own personal computers. How many students do not own personal computers? If 2/5 of the students have personal computers, that means the fraction that do not have is going to be 1 minus 2 over 5, which is 3/5. And we can use that 3/5 to calculate the number of students who do not own, which is 3/5 multiplied by 1200, which is 720. So 720 students do not own personal computers. Pretty much straightforward. Any questions here? Place it in the comments. Hey guys. All right, I hope that was understandable. Let's go on to next question. It says 30% of students who own personal computers also own PlayStations. What fraction of the students in the school own PlayStations? Express your answer in its lowest terms. Right away, if you don't see numbers in this question here, it was meant to check your reading skills. 30%, you go ahead with your pencil in the exam room and put 30% right around there. So you'll know you're dealing with numbers. 30% is 30 over 100. Okay, that's a good exam technique to do. Next, let's answer the question. And don't forget, we want to know if 30% of students who actually own personal computers also own PlayStation. So we have to look at this number too. How many students own personal computers? So the number who do not own is 720. So if 720 do not own personal computers, it means that 1200 minus 720, which is 480 students, actually own personal computers. So the percentage who own who own PlayStations is 30% of the students who own computers. So it's going to be 30% multiplied by 480, which is equal to 144. So the fraction of students who own PlayStations is going to be 144 over 1200, which is 3 over 25. Any questions there? Pretty much straightforward. You guys awesome. Let's continue. So now this is a question that may come as well. Better buy. It says the diagram below, not drawn to scale, shows 2 jars of peanut butter of the same brand. This is brand E and brand B. If you notice, brand E, $2.14 for 150 grams. Brand B, not brand B, jar A and jar B. Jar B, $6.50 for 400 grams. Which of the jars shown above is the better buy? Whenever we're talking about better buy, we mean for the same $1 that we're about to pay, are we going to get the most of anything? Okay, for the $1, am I going to get the most of something? If I'm going to, whatever I'm going to get the most for my $1, that's going to be the better buy. So now let's go. So with jar A, $2.14 equals 150 grams, or we're going to get 150 grams with $2.14. Divide both sides by $2.14. We'll have $1 will give me 70.093 grams for jar A. And for jar B, we do the same process. $6.50 equals 400 grams. Divide both sides by $6.50. $1 will give me 61.538 grams. So which is going to be the better buy, jar A or jar B? Put it in chat, put it in the comments. Hey guys, the better buy is going to be jar E, because for the same $1, I'm going to get more peanut butter than jar B. Are we cool with this? Even though jar B looks bigger, don't be fooled by that. We break everything down to $1. How much is $1 going to give us? Whoever gives us the most of anything for $1, that's going to be the better or the best buy. Let's press on. Let's look at mortgage. I haven't seen mortgage in the people for some time, so it may or may not come. Not necessarily a prediction, but definitely it's good to know. So a house costing $200,000 is bought by a 10% deposit and taking a bank mortgage. A bank mortgage is effectively a loan on the balance that you have to pay to procure or to get a house. So if it's going to be $200,000, the house is costing, which is unlikely, but you just put $200,000, then the deposit that is going to be 10% of $200,000, which is going to be $20,000. All right, so you're just going to put 10 over 100, which is 10%, multiply by 200,000, which is going to be 20,000. Now the mortgage is going to be the price of the house or the cost of the house less the deposit. So it's going to be $200,000, take away $20,000, which gives me $180,000. That's going to be the mortgage that we need to borrow from the bank. It's the loan or the funds necessary, less the deposit. Now then, the total questions, part C says the total repaid to the bank. We have to calculate if monthly payments are $3,250 and are made over a 30-year period. So $3,250 per month for 30 years. You have to find out how many months we're gonna do it for. If we know 12 months is 1 year, then for 30 years, it's gonna be 12 by 30, which gives me 360. Take that 360 and multiply by 3,250. Or you can multiply all of them together. 3,250 multiplied by 30 multiplied by 12, which gives me 1,170,000 or 1.17 million. Any questions there? Yeah, it's great. And let's go on to part D, the interest paid to the bank. The interest paid to the bank is going to be the repaid amount, take away the mortgage. So there's going to be the excess money that you paid in excess of the mortgage. So that interest is going to be 990,000, which is maybe a little bit steep, but the principle is we need to get to know the equations and how to operate them. So the interest is going to be 990,000, and that's the answer for part D. In part E, the total amount for the house is going to be the deposit plus the amount repaid. So how much the person actually bought the house for? It's going to be how much ever the deposit was plus the amount that they repaid to the bank. In this case, it's going to be 1.19 million or $1,190,000. Any questions here? Pretty much straightforward. The most important thing is to learn the requisite formulae for mortgages. All right, and with that, let's go on to topic 2, which is going to be algebra. And these are the subtopics here. So have a look at them. All right, let's move on. Let's look at this question here. Indices. 4c squared multiplied by 3c to the power of 4 over c cubed. Let's use indices to simplify this. It's going to be 12c to the power of 6. How did I get 12c to the power of 6? Because when I multiply indices, I add the powers. 2 added to 4 is going to give me 6. Any questions there? And when I'm dividing indices, I take away the powers. 6c to the power of 6 divided by c to the power of 3 is equal to c to the power of 6 minus 3. And of course, if they're numbers, I multiply them as usual, right? 4 by 3 is 12. Any questions there? Hey guys, great, let's continue. Let's look at this. This is going to be a linear equation where I have to solve for P. As a subtopic as well. P is above the fraction bar or above the fraction line or above the vinculum, and its power is 1. That's 2 conditions. So we know for a fact that this is a linear equation. So let's write those 2 conditions down. How do you know it's a linear equation? 1, the variable is the numerator in a fraction. And 2, the highest power of that variable is 1. Okay, very, very important. Either one or both. That's how we know it's a linear equation, and this is a linear equation. So let's go ahead and solve it. But also we realize that it has a fraction. There's a fraction part. So what we're going to do is, you need to get rid of the fraction. And a great way to do, we're going to multiply throughout by 6. Why am I going to choose 6? Because I want to choose a number that 2 and 3 can go into without leaving a remainder and also be cancelled. So 2 into 2 is 1. Let's choose 6 here. 2 into 6 is 3. Let's say I choose and divide this point by 6 as well. 3 into 3 is 1. 3 into 6 is 2. And if I multiply the left-hand side by 6, I must multiply the right-hand side by 6. When I simplify that, it becomes this. Any questions here? Put it in the chat. All right, any comments there? Place it in the comments as well. Hey, everybody. All right. So at this point, what do we do? Well, before, how did I get 3 here? Well, from here, right? So 3 is going to be multiplied by p minus 1, which is what this is here. And this 2 is going to be multiplied by p minus 2, which is what this is here. That's going to be equal to 6, because 1 by 6 is 6. Pretty much straightforward. Awesome. What comes next? 3 by p is 3p, and 3 by negative 1 is going to give me negative 3. Negative 2 by p is negative 2p. Negative 2 by negative 2 will give me plus 4. And it's going to all be equal to 6. Any questions there? We remove the brackets. That's what happens in the next line. And the next line, we're going to put all the p's on one side and only the numbers on one side. On the same side, but we're going to kind of polarize them, for want of a better word. So it's going to be 3p minus 2p minus 3p minus 3, sorry, plus 4 is equal to 6. What comes next? We're going to say 3p minus 2p will give me 1p plus negative 3 plus 4. So 1p plus 1 equals 6. Now there's no need to place a 1 in front of the p. It's understood. We can also just say p plus 1 equals 6. And if p plus 1 equals 6, what number plus 1 will give me 6? That number can only be 5. Hence, p is equal to 6 minus 1, which is 5. Any questions there? Place a chat, place a comment or question in the comments if you have any. Everybody, any questions here? All right, so let's press on. So we're going to look at the quadratic equation, and we're going to use the method of factorization, right? There are other methods like graphs. There's also quadratic formulae and completing the square. We look at completing the square later on, but for now, we're going to focus on the factorization. So let's go. Identify A, B, and C is the first step to factorization. A is the coefficient of the x squared term, B is the coefficient of the x term, and C is the constant. What does coefficient mean? In this case, the number in front of the x squared. What number do you see in front of the x squared? I don't see a number. So if you don't see a number, that number is understood to be 1. What about the x term? What is the number in front of the x term? Don't make the mistake and say 11. It's not 11. It's negative 11. That's why I have b equals negative 11. And the number without an x term attached to it is c. So we say c is equal to 24. Any questions there? Pretty much straightforward. Next step, we're going to multiply e by c. 1 by 24 will give me 24. Then find the factors of 24 that add up to b, but the product is 24. Interesting, right? So b is going to be negative 11. So I have negative 8 and negative 3. Negative 8 and negative 3, when you add it, you're going to get negative 11. But when you multiply it, you will get plus 24. Take a calculator, take a few minutes, and see if that is true or not. Hey guys, you all confirmed it, I hope. Go ahead and put it in the comments. Next, we're going to rewrite the quadratic with factors from step 3. These are the factors here, so we're going to rewrite this quadratic with these two numbers. All right, let's go. So it's going to become x squared minus 8x minus 3 plus 24 equals 0. Point to note, this negative 11x has been completely replaced by negative 8x minus 3x. The x squared here, plus sign here, 24 here, 24 here, equal sign, 0, 0. Everything is the same, except of course, the negative 11 has been replaced by negative 8x minus 3x, which came from here. Any questions there? Please say Y in the chat or Y in the comments if you are understanding, please, and if you don't. Okay, great. Next. Then we pair them off. I put them in different colors here, but in the exam, what you can do is pair them off in this manner, this way, and this way. So you can better focus on these two and these two. Let's go ahead to the next step, which is going to be step 6. We're going to factorize each pair. factorize this pair here and factorize this pair here. So if you factorize it, you pull out the x in this case. X into x squared will give me back x. X into negative 8x. The two x's will cancel and leave me with negative 8. And there's a trick with it. Whatever you get for here, x minus 8, you immediately rewrite it here. Whatever you get for here, you're going to immediately rewrite it here. And then the next trick is that you're going to say negative 8 will go into the number here, not the x terms, right? Or the x squared term. Whatever number you get here goes into this plus 24, or whatever number you get here without the x term. So negative 8 into plus 24 will give me negative 3. And that goes there. Now we have x into x minus 8 minus 3 into x minus 8. What happens now? Watch carefully if you notice that there's an x minus 8 there and an x minus 8 there. So we can factor that out. So it becomes x minus 8 factored out, and you remain with x minus 3, which is this. Any questions there? Hey guys, awesome. Let's look at this here. When we factorize everything, you get x minus 8 into x minus 3 is equal to 0. Then we look at the zero product. What does the zero product mean? It means if x minus 8 multiplied by x minus 3 is going to be equal to 0, then either x minus 8 is equal to 0 or x minus 3 is equal to 0. One of the two, or both. So if x minus 8 is going to be equal to 0, then x has to be 8, because only 8 take away 8 will give me 0. And if x take away 3 is going to be 0, then x has to be 3. So because 3 take away 3 is 0. So x equals 8, x equals 3. Stated clearly, hence x is equal to 8, comma 3. So we have two values for x. Why is that so? Because the quadratic cuts the curve at 2 points. Our case is going to be 3 and 8. Cuts the x-axis, sorry. The quadratic cuts the x-axis at 2 points. This will be 3 and this will be 8. All right, any questions here? Take a few minutes and look at it. Hey guys, awesome. Let's continue. So in this case, we're going to find the subject of a formula. We want to make P the subject of a formula. Immediately, since there's a square root sign here, you want to square. You want to square this side. Right? Let's go ahead and square that side. Let's get a proper color. Square this side here. I'll square it. And now, if I square the right-hand side, I must square the left-hand side. When you square a square root, you get rid of it. So the result is going to look like this. R squared equals 4 plus 3p squared over s. Any questions there? Next, I need to make P the subject of the formula. What does P be the subject of the formula mean? I have to put P on the left-hand side by itself. Very, very important. anytime you have make something the subject of the formula, find x, find k, find t, whatever, what is meant is that you have to have that letter on the left-hand side by itself. This is a very good working practical definition of making some letter, some variable, the subject. It should be on the left-hand side by itself, but P is on the right-hand side and sitting by itself. So the first things we need to do is get rid of this fraction form. I'm going to multiply the right-hand side by S. And if I multiply the right-hand side by S, I would have to multiply the left-hand side by S. So it looks like this. All right, so next, what I have to do is I'm going to switch it around. So it becomes 4 plus 3p squared is equal to r squared s. I'm getting closer because I'm putting the p on the left-hand side because I want p on the left-hand side. LHS stands for left-hand side. Next, I'm going to put the 4 over on the other side. So it becomes -4. So it's going to be r squared s minus 4. And this 3p squared remains on the left-hand side. We're getting closer because we're going to put p on the left-hand side and it's getting more and more by itself. Next, I'm going to divide both sides by 3 or take the 3 and place it underneath the r squared s minus 4. So we get p squared is equal to r squared s minus 4 over 3. Is p the subject? Put it in the comments. Is it the subject or not? Okay, so it's easy to assume that p is the subject because now I'm saying p kind of by itself. But p is not the subject here. P squared is the subject. So we need to get rid of this square. How do we get rid of a square? We have to square root. Okay, when we square root the p squared, it becomes p, and then we square root the right-hand side in the process. So the final answer is p is equal to the square root of r squared s minus 4 over 3. Any questions there? All right, okay, let's move on to the next question, which is in variation, direct and indirect, or actually direct and inverse variation. So let's look at direct variation first. It says the distance needed to stop a car, d, varies directly as the square of the speed, s, at which the car is traveling. A car traveling at a speed of 70 kilometers per hour requires a distance of 40 meters to make a stop. What distance is required to stop a car traveling at 80 kilometers per hour? This expresses the idea that cars do not stop immediately. When the driver depresses the brakes in the car begins to slow down and eventually comes to a complete stop. And the faster the car is going, the greater the distance the car needs to come to a complete stop. This is what this question is all about. So if the car is traveling at 70 kilometers per hour and it needs a distance of 40 meters to stop, what about when the car is traveling at 80 kilometers per hour? Will it need a greater distance than 40 meters or a lesser distance than 40 meters? Put it in the comments. Hey guys, the answer should be it will need a greater distance. So your answer should be more than 40 meters. Right, so that's a very good idea to start with. It should be more than 40 meters. So in a question such as this, let's suppose this question is in a multiple choice. And they have one answer is going to be, let's say one answer is 30 meters. And what you're going to do is immediately cross this answer out. That's a really good thing to do. Cross that answer out, so you know that's one less answer you have to worry about, because it's traveling at a faster distance or a higher speed, a higher speed. So the distance at which it's going to need to stop has to be greater than 40 and not less. All right, so that's a good strategy to employ for multiple choice. Let's continue. So this is the first thing that you have to do in a case like this of direct variation. You will say D varies directly with the square of the speed. This symbol here means varies. D varies, and in this case, it's going to be varies directly as s squared, which is the square of the speed. What happens next? Then you replace this symbol with an equal sign. And when you do that, you must put in k. K is called the proportion constant or the constant of proportionality. Either one is fine. But just know that you need to put it in. The next thing is you need to evaluate k. What is k? You cannot solve the problem without getting what the number k is actually equal to. So then you have the boundary conditions. The boundary conditions are the values of d and s that they give you. Did they give you? They said a car is traveling at a distance of 70 kilometers per hour and requires a distance of 40 meters to stop. Those are the boundary conditions. So when it's 70 kilometers per hour, it means it needs 40 meters to stop. So what you're going to do is you're going to replace D with 40 and S with 70. So it looks like this. 40 is equal to K multiplied by 70 squared. Any questions there? Hey, everybody. So when you multiply K by 70 squared, you're going to get 40 equals 70 squared K. And then let's make K the subject. If you make K the subject, K is going to be equal to 40 over 70 squared, which is 0.00816. Any questions there? Okay, great. Now that we find the value for K, we're going to rewrite this equation and we're going to include this number here, which is the value for K. So it's going to be D is equal to 0.00816 S squared. And if D is equal to 0.00816 S squared, we can now find the distance required to stop a car traveling at 80 kilometers per hour. We're just going to substitute the S for 80 and multiply. So it's going to be this number multiplied by 80 squared, which is 52.224, which kind of makes sense what we were talking about earlier when we say it has to be greater than 40. And 52.224 is certainly greater than 40. Generally, you should give the answers to 1 dp, unless otherwise stated. But we just left it like that to show the exact value. All right, any questions there? And this question, the answer is also reasonable. It's also reasonable that for 80 kilometers per hour, the stopping distance increased, but not by too much, not by too little. All right, great. Let's continue. We're going to inverse variation, where given that y varies inversely as x squared, and that y equals 3 when x equals 2, calculate the value of y when x is equal to 3. So if y varies inversely as x squared, it means y varies inversely as x squared. That's what this is. Inversely, we have to place a 1 over x squared. And just like before, you have to put this symbol. Now, we're going to replace this symbol here with an equal sign. And when that happens, you must place a key on top of here. Very important, right? So y is equal to k over x squared. Any questions? Hey guys, let's continue. I replaced y and x with these values here. Those, in this case, this is the boundary conditions. When y is 3, x is 4. So y is replaced with 3 and x with 2, right? Not 4, x is 2. But when we square it, it becomes 4. So 3 is equal to k over 2 squared, and 3 is equal to k over 4. Next, hence k will be equal to 3 multiplied by 4, which is 12. Any questions there? So k is going to be equal to 12. So I'm going to rewrite this equation, and instead of placing k, I'm going to put 12 instead. So y is equal to 12 over x squared. Any questions there? Next, I'm going to use this equation to solve. It says calculate the value of y when x equals 3. So x, I'm going to replace x with 3 and calculate what y is going to be. Y is equal to 12 over 3 squared, which is equal to 12 over 9, which is 1 and 1/3. Any questions there? Place it in the comments below. Go ahead and put it in the comments below if you have any questions. Hey guys, awesome. And now, let's carry on, go on to the next topic, which is going to be topic 3, geometry and trigonometry, transformation geometry, solving triangles and circle theorems. All right, so let's go. The diagram below shows the triangle RST and its image R prime S prime T prime after transformation. Describe fully the transformation which maps RST onto R prime S prime T prime. So supposing you were here, this was you, and you want to get to R prime. And you cannot go there directly. Let's see the bridge is down. What you're going to do is hop across 1, 2, and then hop down 1, 2, 3, 4. Now you can only go through the door first, like in this case, we have to go in the X direction and then the Y direction. So to make it easier, you say we go through the door and up or down the stairs. In this case, we are going down the stairs. We're going through the door to the right. So it's going to be 2 or plus 2. And when we're coming down, we're coming down 4. So it's going to be negative 4. And that's the same thing for S. That's the same to S prime. And that's the same thing from T to T prime. Hence, what we say is the transformation is a translation with matrix 2, negative 4. Any questions there? All right, great. So this is what this transformation is, fully described. Now let's go on to the next question. Or the next part of the same question, it says triangle RST is reflected in the line x equals 6. On the graph above, draw the triangle R double prime, S double prime, T double prime, the image of R, triangle RST after the reflection. Write down the coordinates of R double prime. So it's going to be reflected in the line y equals 6. First things first, what is the line x equals 6? What is the line x equals? Let's say x equals 1. That's going to be a vertical line passing through x equals 1. let's say what's the line x equals 4? It's going to be another vertical line passing through 4. Now, because it's called x equals something, that means it's a horizontal line. Quite the reverse, right? It's going to be a vertical line passing through that particular point. So the line x equals 6 is actually a vertical line passing through this number of 6. Any questions there? Hey guys, great. Let's reflect this, right? Imagine this is the mirror line or the mirror. We're going to take this whole triangle and reflect it, flip it over on this side. So it becomes like this, and that's R double prime, S double prime, and T double prime. So what is the coordinates of R double prime? If we start at O, the origin, you have to hop across until we reach 10. And from 10, we go up 1, 2, 3. So the coordinates of R double prime are going to be 10, 3. Any questions there? All right, awesome. All right, so this is going to be this is going to be the reflected diagram or reflected image of RST in the line x equals 6, where R double prime, S double prime, and T double prime all mirror the RS and T. And the coordinates of R double prime are 10, 3. How did we get 10, 3? Again, we started at the origin. We jumped until we reached 10 to come directly below R double prime, and then we walked up 1, 2, 3. So you always go the x-axis first and then the y-axis. You cannot see it's 1, 2, 3 and then come across 10. That's wrong. It's always x before y, just in the same manner that x comes before y in the dictionary, in the alphabet. Simply as well, it's always x before y. Or you can remember it as you have to go through the door and then go up or down the stairs. Let's continue. So in this case, what is the answer? The diagram below shows the triangle ABC and its image A prime, B prime, C prime under single transformation. If you look carefully, it appears as this object or the triangle is being pushed in that direction, right? So it's definitely going to be a rotation. It was horizontal here, now it's actually vertical. So it's a rotation in a clockwise direction, and the angle of rotation appears to be 90 degrees. Okay? And the center of rotation is going to be the origin. Easy way to figure that out as well. What we can do is draw a line from C to C prime. Get to the middle of C to C prime. If you have a protractor, you should have a protractor. Get a protractor. Place it at the midpoint on this point here, and then measure 90 degrees. That 90 degrees should be somewhere around here. And then draw a line coming straight this way. And if you do the same thing from B to B prime, and draw a line coming on the center, that's actually where the center of rotation is. And you can do that if you do an accurate drawing. So in this case, the center of rotation, we know for a fact, is going to be the origin. So it's a rotation 90 degrees clockwise and above the origin. Any questions there? Guys, let's continue. Right, so the question says the translation vector T4 -5 maps triangle E prime, B prime, C prime to E double prime, B double prime, C double prime. So this is E prime, B prime, C prime. So we're gonna map it 4 to your right, 1, 2, 3, 4, and -5 coming down. 1, 2, 3, 4, 5. What about B to B prime? Same process as well as C to C prime. Let's try C. C, 4, you jump 1, 2, 3, 4 across, and then we come down 1, 2, 3, 4, 5. Similarly for B, it's going to be 4 across and 5 down, and where all the points meet up, or at the end, you just simply connect the dots and make a triangle. Any questions there? Great. Let's press on. So we are into solving triangles as we ended it on 1. And to solve this triangle, we actually have to find, let's find this length here. And this length is going to be x. We can use the cosine rule. X squared is equal to 75 plus 100 squared minus 2 by 75 by 100 by cos 32. This is all the cosine rule. And one key note is that the x should be facing the 32. That's how you should do the cosine rule always. Next, put all this into the calculator. X squared is equal to 2,904.279. So x is going to be the square root of this, which is going to be equal to 53.891 meters. That's the length from here to here. Any questions here? Awesome. And let's look at this question here. The diagram below, not drawn to scale, shows a vertical tower BT with a flagpole TP mounted on it. A point R is on the same horizontal ground as B, such that RB is equal to 60 meters, and the angles of elevation of T and P from R are 35 degrees and 42 degrees respectively. So we're going to label the diagram to show the distance 60 meters, the angles of elevation 35 and 42, and the right angles, sorry. So there's going to be 60 meters, that's going to be 35, that's going to be 42. That's a right angle, okay? Once they are vertical and horizontal meeting, it's always at right angles. The question then says, calculate the length of the flagpole, giving your answer to the nearest meter. So what we're going to do is look at this drawing more closely. You have PBR and the right angle there, 42 degrees. What we're going to do is we're going to find the flagpole is this piece from here to here. So if we can find this whole length and subtract it from this length, we will get the length of the flagpole. Okay, so this here is this whole length here. So the next step is we're going to find this length here. But first, we have to find the PB first, which is the total length from the ground to the top. Let's go. That part is going to be O. Let's designate it as O, because I'm going to use sine or cosine or tangent in order to find out this length. But it cannot be cosine, right? Because cosine doesn't have any opposite. But nonetheless, let's continue. It's definitely going to be h because it's going to be opposite in 90 degrees. This has to be, that's the remaining side. Now we're going to use SOHCAHTOA. And because we have an opposite and adjacent, we're going to use the TOA, which is what this is here. Tan theta is equal to opposite over adjacent. So in this case, we want the opposite, which is the PB. What we do is we're going to cover our finger, and the rest of the formula tells, the triangle tells us the formula. So it's going to be tan multiplied by the adjacent. So we already know that tan 42 is going to be equal to opposite, which is this opposite over adjacent, which is 60. So to find the opposite side, which is PB, we're going to say it's going to be equal to tan 42 multiplied by 60, which is 54.0242 meters. Any questions? That's the height from PB of PB, which is height from the tip of the flagpole to the ground. Any questions there? Great. Now, we're going to say so far for triangle PBR, O is equal to PB is equal to 54.024. Right? So that's from the ground to the top of the flagpole. So we can call that, right, FP. Top of the flagpole is going to be called FP. Now, for triangle TBR, which is this triangle here, TBR, O is equal to TB. From here to here is O, which is TB, because we have a new O for the triangle TBR. And that's going to be equal to tan 35 multiplied by 60, which is 42.0125. So we use the same principle that we used to get this height. It's the same principle we used to get what TB is. Tan 35 multiplied by 60, which is 42.0125. So we have the distance from here to here, and we have this distance from here to here. So all we need to do right now is subtract them. So the height of the flagpole is the difference from, which is equal to PB minus TB, which is 54.04242 minus 42.0125, which gives me 12 meters. Right, to the nearest meter, because that's what they said, to the nearest meter. Any questions here? So this is one way to solve a triangle, which is part of the subtopics for CSEC. Now, let's get into some circle theorems. As we are familiar with this circle here, which is the Earth, imagine a ray of light just grazing the surface of the Earth. We'll call that ray of light a tangent. Next, imagine a line drawn from this, where the tangent is coming from, and going towards the center of the circle, in this case, the center of the Earth. Then the angle formed between the tangent and the radius is going to be 90 degrees. Okay, so this is the radius, this is the tangent, and the angle between a radius and a tangent is always 90 degrees. And the point where the tangent and the radius meet is called the point of tangency. All right, any questions there? Next. Don't forget, it could be radius or it could be diameter. So we can use also diameter, and it will still be 90 degrees. So it doesn't have to be a radius. It can be a diameter as well. All right? But the original theorem, I believe, had radius in it. So the angle between the tangent and the radius drawn from the same point of tangency is going to be 90 degrees. That's what this theorem says. And it can be a radius or it could be a diameter. Right? So as the plot twist says here, the theorem works with the diameter as well. So let's look at a question, the theorem first, and then a question. That's a radius. It can also be a diameter. That's a tangent. And this is going to be 90 degrees. It's the point of tangency where the radius and the tangent meet. All right, any questions there? Awesome. What comes next? Let's look at a question that exemplifies this idea. This is a radius. This is the tangent. This is the radius. Where they meet is going to be 90 degrees, and we can use Pythagoras' theorem. Okay, so we see the inclusion of Pythagoras' theorem as well into some of this stuff. We can use Pythagoras' theorem to find out what x is, and that would be x squared is equal to 5 squared plus 12 squared. X squared is equal to 25 plus 144. X squared is equal to 169. Hence, x is equal to the square root of 169, which is equal to 13 centimeters. Any questions here? Hey guys, pretty much straightforward, right? No questions. All right, let's continue. So we're going on to topic 4, relations, functions, and graphs, functions, composite functions, etc. So the function is defined as f of x maps onto 3 minus 2x. Right away, don't forget, this is the same as saying, let's get the proper color. This is the same as saying f of x is equal to 3 minus 2x, right? These two are exactly the same, so don't be confused at all. F of x is equal to 3 minus 2x is the same as saying f is such that x is maps onto 3 minus 2x. So if that is so, then the diagram below is a mapping diagram of this function, f. Determine the value of a. A is in the codomain or the range. X, these numbers here are definitely in the domain. So to get from 2 to -1, let's see a pattern and see if we can figure out what A will be. To get from 2 to -1, so every time we go up one level, let's look at the first one. 3 minus 2 multiplied by 2 gives me -1. This 2 here is this 2, and it comes from this x. Okay, this x is being replaced by 2, and in the next one, this x is being replaced by 1. Next one, this x is being replaced by 0. So in this one here, last one, the x will be replaced by -1. And when we put this into the calculator, we work this out. 3 minus 2 multiplied by -1, that will give me +5. Okay, -2 by -2, -2 by -1 will give me +2, +2 plus 3 will give me 5. So A is equal to 5. Pretty much straightforward. Any questions there? All right, great. Well, let's look at this question here. It says, determine in their simplest form expressions for the inverse of the function f inverse of x. Okay, so we do the old-fashioned way, and then I'll show you a slightly different way. We can say f of x is equal to 3 minus 2x. We're going to let y equals f of x, which means y is equal to 3 minus 2x. Then we're going to make x the subject. 3 minus 2x is equal to y. Next, negative 2x is equal to y take away 3. And x is equal to y minus 3 over negative 2. So the inverse of the function is, or the last step, we interchange x and y. So y is equal to x minus 3 all over 2. And then we replace y with f inverse. F inverse of x is equal to x minus 3 over 2. Any questions? Yes, so this is going to be the f inverse of x. Now, we can get the same answer if we do a slightly different way. So I hope you all can take that down or take a snapshot. Right, so what we can do as well, we can say f of x is equal to 3 minus 2x, and then we're going to rewrite it as f of x is equal to negative 2x plus 3. Right, we put the negative 2x in front. Now, because the negative 2 is joined to the x by multiplication, and we are finding the inverse. What's the inverse or the reverse of multiplication? It's going to be division. So we can divide throughout by negative 2 and reverse this sign. When I say this sign, we could reverse this sign. And we will get the answer as well. It's going to be divide through by negative 2 and reverse this sign from a plus to a negative. And lo and behold, we got the very same answers as before. Any questions there? Right? If you can kind of see it. If you can kind of see it in the, right? This is the y minus 3 over negative 2. This should have been negative 2 here, right? And this is negative 2 here. So it's going to be f inverse of x is going to be x minus 3 over negative 2, which is the exact same thing as this. Okay? In the exam, choose the method that you're most comfortable with. That's the best way to go. Now then, let's get to the composite of a function. The composite of a function, f2x, I've seen this a few times in CSEC within recent years, and they seem to be ramping this up. So what is the composite of a function? This first, what this is not. This is not f squared. Do not forget this. It is not f squared. It is f2 of x. Okay, nothing is being squared here. This means we are finding this function of a function. That's what the composite function means. It is not function multiplied by a function. That is completely 100% wrong. If you do that in the exam, you will get this question wrong. The composite function f2 of x is what we are chatting about here. So let's see how we're going to interpret that. So don't forget f of x maps onto 3 minus 2x is the same as saying f of x is equal to 3 minus 2x. Now, a function of a function of x means function of a function of x. Now, in this case, let's look at the first case first. We have f of x in the brackets. In the second case, we have f of a function of it, a function of x. So f of x here takes the place of x. Okay? So I no longer have f of x, I have f of x. So whatever x does, f of x is going to mirror. X is being multiplied by -2. That's what's happening with the x. So f of x is going to mirror the behavior of x as well. So you will have 3 take away 2 multiply by f of x. Okay, any questions there? See that in, tell me if it's making sense to you. You guys awesome. So at this point, what do we do? We simply complete the change. So 3 minus 2 into, what is f of x? F of x is 3 minus 2x. 3 minus 2x. So I'm going to put 3 minus 2x into here. Next, I will say 3 minus, I'm going to remove the brackets. -2 by 3 is going to be -6. And -2 by -2x is going to be plus 4x. Next, from here on in, it's simply algebra. 3 minus 6 is going to be -2 plus 4x. Any questions there? What you all think about that? Now, let's contrast what we did on this side with what we're going to see happening on this side. Right? f2 of x is f of x. So far, so good. So what we have, which is f of x. Good. Next, f of x is equal to f of 3 minus 2x. Okay? Which we're going to do, we're simply going to put f of x, the value of f of x in the brackets there, or the expression of f of x goes into the brackets. Next, we're simply going to equate f of 3 minus 2x and make it mimic whatever x does. So it's going to be 3 minus 2 into f of x. Then we replace f of x with 3 minus 2x in this line here. Right? So we should get 3 minus 6 plus 4, which gives me 4x minus 3. A correction there. It should actually be 3 minus 6 is -3, not -2. Okay? Which is the same exact thing that we get on this side. So choose either way that makes it simple for you. All right, awesome. Let's continue. So what we're going to do now is take the value of f of minus 2, f of f inverse of minus 2. First, we recall that f inverse of x is x minus 3 over -2. So f inverse of minus 2, I'm going to replace x with, wherever I see it in f inverse of x, I'm going to replace it with -2. -2 minus 3 over -2 is equal to -5 over -2. -5 over -2 is the same as saying 2.5. So f inverse of -2 is 2.5. So in other words, this portion here this whole portion here is actually simply 2.5. Which brings me to my next statement. I'm going to say f of f inverse of -2 is simply f of 2.5. What is f of 2.5? I'm going to put 2.5 and replace and put it into f of x, which is here. So this is f inverse of x, which we got to be 2.5. But now I want to find f of f inverse of 2. Knowing that f inverse of 2 is 2.5. So it's going to be f of 2.5. I'm going to place the 2.5 into this function here. So I will have f of 2.5 is equal to 3 minus 2 multiplied by 2.5, which gives me -2. So it's going to be 3 take away 2 multiplied by 2.5. When you put that in the calculator, you will get 2, -2. Okay, any questions here? All right, so let's just try look at it one more time again. First, we know that f inverse of x is going to be x minus 3 over -2. So f inverse of -2, we're going to replace the x with -2. Simplify the top, we get -5. We have -2 at the bottom. So -5 over -2 will give me 5 over 2, which is 2.5. Hence, f inverse of -2 is 2.5. That's what I have here. F inverse of -2 is simply 2.5. So f of f inverse of -2 is actually f of 2.5, which is what I have here. So we go back to f of x to evaluate f of 2.5. And we're going to replace the x in f of x with 2.5. So the 2.5 replaces this x. So it becomes 3 minus 2 into 2.5, which gives me -2. All right, so take a minute and see if it makes sense to you. Hey, everybody. I hope you understand it. Go ahead and rewind the recording until you get a clearer understanding of it. All right, in the meantime, let's press on to the next question, which incidentally, this question is actually a form of linear programming, right? Where you have to use a ruler and draw these lines on the grid, and I'll show you in a second what do I mean by that. So let's draw the line x equals 1/2. Remember before we said x equals anything is going to be a vertical line. So if you want to draw x equals if you want to do the line x equals 1, it's going to be looking like this, coming straight down. X equals 6 is going to be this line. So where is x equal 1/2? X equal 1/2 is somewhere between 0 and 1. In fact, exactly between 0 and 1. So x equals 1/2 is going to be a vertical line passing through the point, the x graduation of 1/2. Okay, so x equals 1/2 is not a horizontal line, but rather a vertical line. Why? Because every point on this line, the x coordinate is going to be 1/2. That will help you locate the x equals 1/2 line as well. Next, the line y equals x. Everybody knows this line. It's a line drawn exactly in the middle. So for every value of y, we have the same value of x going up on the line. And the line x plus y equals 5. How do we get that line? Well, first thing what we should do is put x equals to 0. If x is equal to 0, just like linear programming, x is equal to 0, y will be equal to 5. So it's going to be on this line here. X is equal to 0 on this line, so y is equal to 5. And then we're going to put y is equal to 0. But if y becomes 0, then x will be equal to 5. So we come here and we place our x here. And next, we simply connect those two lines. All right, any questions there? Hey guys, finish moving it over. Okay, great. Let's press on. I'm going to show you how this is actually, or before we go on, just as an exercise, the line x equals 3, where's the line x equals 3 going to be? It's going to be coming up on this vertical line here. On the line, wherever x is 3 on the x-axis, cutting the x-axis. And the line y equals 6 now. Now, before we had the line x equals 3. But now, what about the line y equals 6? The line y equals 6. This line is going to be a horizontal line. This way. Okay? So anytime you have like y equals 3, y equals 4, y equals 5, etc., that's going to be a horizontal line. If you have x equals 1, x equals 2, etc., that's going to be a vertical line. So don't forget that. Let's press on. And this question says, on the grid, label as R the region where x is greater than or equal to a half, y is greater than or equal to 5, and x plus y is less than or equal to 5. Pretty much straightforward. This is the line x equals a half, so anything greater than will be on this side of the line, coming down here. And y is greater than or equal to x will be above this line, above the line y equals x, which is this region here. That's the region y is greater than or equal to x. And x plus y is less than or equal to 5 will be underneath this line. It's going to be underneath this line, which is x plus y is equal to 5, so it's going to be underneath this line. So what you have to do is look at the graph and see where the purple, brown, and blue strokes all intersect. And that can only be at this point here. And that's where R is going to be, right? And if you've seen the R clearly, but that's exactly where the R is going to be, right here. And this is exactly what linear programming tends to do. So in the exam paper 2, you will have you may have linear programming similar to this. Be aware of it. All right. Next, let's press on to topic 5, measures of central tendency, grouped and ungrouped data, probability, cumulative frequency, etc. Statistics. So let's look at this question. A farmer harvests a sample of 80 beans and weighs them to determine their maturity. Below is a table of her observations. So these are the weights of the seeds, the beans, that is, and this is the frequency, which means, so in this case, it means 3 beans had a weight of between 0 and 10. 14 beans had a weight of between 60 and 70 grams. Let's construct a frequency column. The first number is always going to mirror the first number of the frequency, and the last number is always going to be how many of any one thing that you have. So let's prove that. 3 plus 5 will give me 8. 8 plus 5 will give me 13. 13 plus 9 will give me 22. 22 plus 11 will give me 33. 33 plus 15 will give me 48, and so on. And true to form, the last number here is how much of the thing that we have, the n. And the first number here is always going to be the first number in the frequency. Any questions here? What you all think? Put the comments in the down and let me know what your understandings, what your comments are. Hey guys, awesome. Let's continue. What we're about to do now, we're about to draw a cumulative frequency curve. Let's get the midpoints of the weights. It's going to be 5, 15, 25, 35, 45, etc. The midpoints are simply the midpoints, right? The middle of 10 and 0, middle of 20 and 10, etc. So one thing you can do is add the both ends and divide it by 2. All right. That will give you the midpoint. And what you're going to do next, you're going to use the graph and construct a frequency curve. Right? And I'll tell you the name in a second. So when it is 5, we're going to plot it as 3. 5 in the midpoint, 3 on the cumulative frequency. When it is 15, we plot it as 8. So let's open it up and see it more clearly. When it is 15, just between, it's supposed to be exactly on 8, right? Sometimes it could be off, but it shouldn't be off by much. Similarly, we have it when it is 25, it's 13, etc. And then what you should do is draw a nice smooth curve going throughout all the points. And sometimes CSEC will ask you questions like this. Find the median weight. The median weight, what you're going to do is you're going to find the weight of where half falls exactly. So it's going to be 80 divided by 2, which is going to be half. Draw a horizontal line, make it hit the frequency curve, and then bring it down. And in this case, the median weight is 50 grams, but it's not always going to be so, right? So be careful. By the way, the name of this curve is called an ogive. So you can see that as well. Draw an ogive. That's the name of this curve, right? These are not two words or exclamation. The whole word is ogive, no spaces. And they may ask you to find the probability. Let's say the probability that the weight of the beans is going to be less than 40 grams. Draw a vertical line from 40 grams, go up to the curve and come across from the curve. And we have this figure here, which looks like 26. Yeah, looks like 26, which is here. 28, 30. So it's going to be 26 out of 80 is going to be the probability, which gives me 13 over 40 as the probability. The more accurate your drawing is, the more accurate will be these parameters, right? So strive for accuracy, most important. But make sure that the midpoints are correct and the cumulative frequency calculations are also correct. All right, so take a second and examine it. Awesome. Let's continue. Let's get on to our other topic, which is measurement problem, right? And all the subtopics there. So let's look at this question here. It says the diagram below shows a rectangular tank with base 50 centimeters by 40 centimeters that is used to store water. The tank is filled with water to a depth of 15 centimeters. Calculate the volume of water in the tank. The volume of a cuboid is going to be length by breadth by height, which is 50 by 40 by 15, which gives me 30,000 cm cubed. That's the volume of the tank. Pretty much straightforward. Any questions there? Next, a cylindrical container shown in the diagram below is used to fetch water to fill the rectangular tank. The container, which is completely filled with water, has a radius of 20 centimeters and 21 centimeters in height. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. So rectangular tank actually simply means a cuboid, right? There's no such thing as a rectangular tank in mathematics. We call it a cuboid. And a cylindrical container is simply a cylinder, right? So this is 3D volume shapes where they are testing your use of knowledge, your formulae. And don't forget, if you get stuck with the formula, go back to the front of the booklet where all the formulae are stored. That's definitely might help you in the exam. Okay, awesome. So the volume of a cylinder is going to be pi r squared h, which is 22 over 7 multiplied by 20 squared multiplied by 21, which gives me 26,400 cm cubed. Next, so the total volume is going to be 26,400 plus the 30,000 from before, which gives me 56,400 totally in the rectangular tank right now, or the cuboid. Hey guys, any questions there? Go ahead and put it in the comments. Now then, show that the new depth of water in the rectangular tank is 28.2 centimeters. What you should do is have the volume of a cuboid and then place the height of the tank, okay, as the value for each. And check to see if the volume of water that you calculated from before, which is 56,400, is going to be equal to the volume if you calculated using L by B by H. And if you do calculate it, you'll find that the left-hand side is equal to the right-hand side, so it's shown. What you should not do is don't make H the subject and solve, right? That would just take you in a different direction. Just show that the left-hand side is equal to the right-hand side. Now then, let's press on to the next question. The vertical height of the rectangular tank is 48 centimeters. Determine how many more cylindrical containers of water must be poured into this rectangular tank for it to be completely filled. The volume of the tank is going to be, we now find the volume because we found the height of the tank. So the total volume of the tank is going to be, total volume of the tank is going to be 40 by 50 by 48, which is 96,000 cm cubed. So the remaining volume is the subtraction of the 56,400 we had from before from this new volume that we are now made aware of. So 96,000 take away 56,400 is going to be 39,600. So it says how many, they're focusing on the cylindrical container. How many of those cylindrical containers will it take to fill this up? Well, it's easy. If you know that one cylinder is 26,400, then what we're going to do is divide 39,600 divided by 26,400, and we need 1.5 containers again. Do not round this off to 2. That will be an error. Okay, because you can't get 0.5 containers in this case. Any questions there? Okay, awesome, great. Let's continue. Now we get to topic number 7, the investigation, manipulating patterns and sequences. So let's look at this question here. The diagram below shows a sequence of figures made up of circles and dots. Each figure has 1 dot at the center and 4 dots on the circumference of each circle. The radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle. Except for the first figure, a portion of each figure of the other figures is shaded. Okay, interesting problem. Complete the rows in the table below for figure 5 and n. So these are the rows here, this row and this row for figure 5 and figure n. You have to complete it. Most important thing is to get context clues. Context clues is to observe the pattern that came before and then use that pattern to predict what is about to come. Do you understand that? That's very, very important. So a pattern enables you to foretell effectively what a new pattern is going to bring. We see that in life, we see that in everyday living as well. Weather patterns, we talk about weather patterns, we talk about economic patterns, etc. So in this case, what we're going to do is we're going to look at the context clues that come, the pattern that comes before. So if you go from 5 to 9, be plus 4. If you go from 9 to 13, be plus 4 again. 13 to 17, be also plus 4. Hence, from 17 to this point, because we go from 4 to 5 directly, we're simply going to plus 4 to the 17 to get 21. Any questions there? All right, guys, let's continue. Let's look at this blank here. What is the pattern coming on here? This is plus 2, and 5 to 7, we also have to plus 2, so 7 to the next one, which is directly after 4. We're going to plus 2 to the 7 to make it 9 pi. Let's watch the pattern coming on here. It's a bit different, right? So let's check it out. So this one is going to be plus 4, plus 6, and from 12 to 20, you're actually plussing 8. So from 20 to the other one, you're going to be plussing 10 or adding 10. So it should be 30 pi. Any questions there? Hey guys, making sense so far? All right, so let's go to the row of n. When we get to the row of n, because we have a regular pattern coming down, right? A regular pattern from here to here. This is going to be 4, 4, 4, and 4. You know that somewhere along the lines, 4 is going to be involved in this general pattern. The 4 and the number, whatever number we have here. So 4 plus 1 is 5. It works for this. 4 plus 2 is 6. It does not work for this. Let's check it again. Let's say 4 by 1 is 4. Plus 1 will give me 5. It works. 4 by 2 is 8. Plus 1 will give me 9. It works for here. 4 by 3 is 12. Plus 1 will give me 13. It works for here. It works for this one. 4 times 4 is 16. Plus 1, it works for here. 4 by 5 is 20. Plus 1, it works for here, which gives me 21. So, based on that, we can tell that the general pattern of the number of dots is going to be 4n plus 1. Any questions there? Make sure include the 4 will have to be included somewhere. Hey guys, does that make sense to you? Pretty much sensible. All right, so let's look at the other one. In this case, we have a regular pattern coming down as well. Whenever you see a regular pattern, it goes down, this comes down by 2. This comes down by 2 again, by 2 again. If you have a regular pattern repeating, in this case is 2, 2, 2, you know it's going to be a linear equation just like this. This is a linear equation, and you'll have some kind of linear pattern, and the number 2 is going to be involved, and somehow working with this. Okay, so if you say 2 multiplied by 1, it's 2. It doesn't work for here. But if you say 2 by 1 is 2, and we take away 1, let's see if that works. 2 by 1 is 2. 2 take away 1 is 1. 1 pi, it works there. What about this one? 2 by 2 is 4. 4 take away 1 is 3. 3 pi, it works there. It works for this one. 2 by 3 is 6, minus 1 is 5. 2 by 4 is 8, minus 1 is 7. 2 by 5 is 10, minus 1 is 9. So it works here. So it means that the general pattern should be 2, or before we get to that 2n minus 1, we should get to the n squared, but we come back to the n squared pi. So it works for here, which is 2n minus 1 into pi. So let's see how they got the n squared pi here. Now in this case, it didn't come down by the regular pattern. Okay, if you all see that, it came down by, it kept varying. So in this case, we had, it increased by 3, and from 4 to 5, 4 to 9, it increased by 5, it increased by 7. It kept increasing every time. Okay, from 16 to 25, it was 9. So it kept increasing every time. So which means to say it's not going to be a linear pattern. It's going to be a squared or a cube, most likely a squared. So you play with that squared, and you play with the numbers. So try 1 squared. 1 squared, it works for 1. 2 squared is 4, it works here. 3 squared is 9, it works. 4 squared is 16, it works. 5 squared is 25, it works. So it should be n squared. All right. Any problems there? Are we cool with this? Awesome. Now let's look at the last one. We have 2 pi, 6 pi, 12 pi, etc. So this goes down by 4. This goes up by 6. This goes up by 8. This goes up by 10. So in this case, the increase is not constant. It goes up every time. It changes. So therefore, it might have a squared pattern. So it should be n squared something. So let's play with it. If we have, the first one is 1, 1 squared, plus 1 is 2, that works. 2 squared, which is 4 plus 1 is 5, that doesn't work. 3 squared plus 1 is 12, is 10, and it doesn't work for 12. So we should develop some other pattern to make it work. Okay? So let's try it. Let's see what else we can come up with. Any ideas? All right, good. I'm seeing 1 or 2 people in the chat. So let's do 1 squared plus 1. 1 squared plus 1 is 2. That works. 2 squared plus 2. 2 squared is 4. plus 2, which gives me 6. 3 squared is 9. 9 plus 3 gives me 12. That works as well. 4 squared is 16 plus 4 gives me 20. That works. 5 squared is 25 plus 5 will give me 30. So in general, it should be n squared plus n. Okay, so a good way to figure this out is look at the pattern coming down. Those are the context clues. Look at the pattern coming down. If the pattern is a regular pattern like 4, 4, 4 or 2, 2, 2 or whatever, it's going to be a linear equation. Linear, linear. If it keeps increasing by a different number every time, chances are it was going to be a quadratic. We're not really going to say quadratic, but a squared equation. All right? But quadratic is the proper word as well. Nothing's wrong with saying quadratic. All right, let's continue there. So it says, determine the value of n when the number of dots in figure n is 541. So what we're going to do is we're going to put 4n plus 1 equal to 541, and then we're going to solve, make n the subject of the formula. So it's going to be 4n is equal to 541 minus 1. Next, 4n is going to equal to 540. And n is going to be 540 over 4, which is equal to 135. So n is going to be 135 when there are 541 dots. All right, so we take this value here, this general expression, and set it equal to 541, and then solve for n. What you do not want to do is to keep coming down here, 9, 13, until you reach 541, right? That's a foolhardy technique to do, especially in a time-bound exam. The exam will be for a specific time. By the way, you will see later on that you should not spend more than 14 minutes on any question in paper 2. So if you're bounded by time, there must be an easier way to figure the questions out. Okay? Awesome. Let's continue. So it says here, write down in terms of p and pi the area of the largest circle in figure 3p. What is the area of the circle, of the largest circle in figure 3p? Well, in figure n, the area of the circle is going to be n squared pi. So therefore, the area of the largest circle in figure 3p, which we don't know, we're going to replace n with 3p. For figure 3p, n is equal to 3p. And it means the area of the largest circle is always going to be n squared pi. But now n is 3p, so we're going to put 3p in place of n. So it's going to be 3p squared pi, which is equal to 9p squared pi, and that's going to be the area of the largest circle in figure 3p. You want to catch this? So what they're saying is that use this formula to find the largest outer area. But in this case, we have figure 3p. We have figure 1, figure 2, figure 3, figure 4, figure 5. But for some reason, we have a figure called figure 3p. So now we're going to put 3p in place of n, square it, multiply by pi, and this is the result. Any questions there? Hey guys, awesome. Let's continue. Now we get to vectors and matrices. Let's press on. So let's construct a vector equation for this display here. So we want to get from E to O, and then from O to B. This is an example of the triangular law, right? So if you want to say AB is from E to O and then from O to B. A good way to execute the triangle law of vectors is to remember that the first letter here should be the first letter here. The last letter here should be the last letter here. And the letters on the either side of the plus sign should be the same. That will help you a great deal in figuring out the triangular law of vectors. So AO, to get from A to O, we are going through the door to the left. We are hopping across how many to the left? We are hopping across 1, 2, 3, 4. 4 to the left, so it's going to be -4. Are we going up or down to get from A to O? Right? Remember, from A to O, we are not going up or down. We're going straight across. So it's going to be -4, 0. And then to get from O to B, we are not going left or right. We're not going through the door at all. We're coming straight down the stairs. How much are we coming down? We're coming down 1, 2, 3, 4, 5. So it's going to be 0, -5. Let's put it here. So it's going to be AO and OB are vectors, are also vectors, right? Don't forget that they are also vectors besides just AB being a vector. So if AO is -4, 0, which is what we just got, and OB is 0, -5, which is what we also just got, then AO plus OB is -4, 0 plus 0, -5, which gives me -4, -5. Any questions there? Hey guys, great. Let's continue. Now, let's look at this question here. It says the position vectors of the points P and Q relative to the origin O are OP is 4,3, OQ 5,0, respectively. The diagram below shows that PR is equal to 3OP. Where's PR? PR is equal to 3OP. And QS is equal to 3OQ. Expressed in terms of the XY, the form XY, the vector OS. Right? Where's O? O is going to be here. And OS and S is going to be here. So to get from O to S, and if we know that the OQ will be most likely part of the OS journey. In other words, there'll be multiple OQs that we can traverse before we get to S. So let me show you what I mean. Right? To get from O to S, I'll have to go from O to Q, and then Q to S, which is what I have here. From O to S, I'll have to go from O to Q, and then from Q to S. Don't forget what we said before, the first letter here, the last letter here, the last letter here. And the letters in between the first and the last is the same, or on either side of the plus sign. That's a really good way for applying the triangular law, and you'll get the correct result every single time. Again, same letter. Now then, what is OS? OS is equal to 50. Where did I get 50? Right. So because OQ is 50, that's why OS is 50. Plus sign, plus sign. QS is 3OQ. So we have that there. Let's write it out. Let's further simplify it. But OQ is what? 50. So 3OQ will be 3 multiplied by 50. Next, It's going to be 50 plus 3 by 50, which is 15, 0. Next, OS is equal to 20, 0. Any questions there, which makes sense because we are going straight across and we're not going up or down to get to the S. Does that make sense, everybody? Please a comment if you think it makes sense. Hey guys, let's continue. Now it says here, express in terms of x, in the form xy, sorry, the vector pq. Same idea. Do you see that? We're going from P to Q. So we go from P to O first, then you want to go from O to Q. Let's write it down. P to Q equals P to O plus O to Q. Again, don't forget, first letter, last letter, last letter. And the letter on either side of the plus sign is the same. Is that clear to everybody? Great. What happens next? What is PO? PO is negative OP. What do you think about that? To get from P to O, I have to go the opposite direction of OP. So what I do is, I look around at the question. And I ask myself while I look around at the question, do I see PO anywhere? I don't see PO anywhere. I see OP. But that's not a problem. Because what I can do is, I can simply reverse the direction. PO is where I want to go, but I only have OP. So all I have to do is put negative OP next to POP. Negative sign, sorry, next to OP, and it becomes PO. So it's going to be negative OP plus OQ, which is what we have already. So all we need to do is place a negative sign in front of all these numbers and then add them to OQ. Negative 43 plus 50 is negative 4, negative 3 plus 50. Negative 4 plus 5 is going to be plus 1. Negative 3 plus 0 is going to be negative 3. So PQ is actually 1, negative 3. What does that mean actually for us? Right, so almost always derive meaning from mathematics. So PQ is going to be 1, negative 3. So if that means if you're standing at P, which is here, let's say we're standing here at P, and we want to get to Q. We're going to go 1 block to the right. And then when we reach here, we come down 1, 2, 3, which is symbolized by negative 3. You all see that? Let's do that again. So if we're standing at P, in order to get to Q, we're going to go 1 block to the right, and then we're going to come down 3 steps. That's what this negative 3 means. And it's logical and it makes sense. All right, so just take a second and take it in. Hey guys, awesome. Let's continue. Right, don't forget the O, you have the same letter on either side of the plus sign to begin with, right? It doesn't matter too much here once we ensure that it is here. And because everything we do from here on flows from this point here. So once this point is intact and in order, everything else will naturally flow. All right, awesome. Let's continue. Let's look at the question here. It says the diagram. Oh, we have to find RS. This and if you can hardly see it, the vector RS. So R is supposed to be around here. Yeah, this is R. This is us standing at R, and we want to get to S, right? But the bridge between R and S is broken down. So what can we do? Let's make a new way. So RS is equal to RO plus OS. Making sense? So RO, let's go from R to O, and then from O to S. Don't forget, we can't necessarily get to we can't go directly there. So we have to go around. Remember, the letters are the same, very important. Now, RO is negative 4OP. From R to O, yeah, is negative 4OP. It makes sense, right? Because from P to R is 3OP, and O to P is OP. So from O to R will be OP plus 3P. See that? You have three small OPs coming on here, and we have another OP coming here, but in a totally different direction. 1, 2, 3, 4. That's why RO is negative 4OP. Any questions there? Hey guys, great. So let's work it out now. We're going to replace this RO with negative 4OP. So therefore, RS is equal to negative 4OP. We're going to replace this RO. Negative 4OP plus OS. What is negative 4OP? It's going to be, right, so we get this way, and then we go to this way. So this is just us completing the journey before we even started, or mapping out the journey before we have even started. So it's going to be negative 4 into 4, 3 plus 20, 0. Where did this 4, 3 come from? OP is 4, 3. So negative 4 OP is going to be negative multiplied by 4, 3. Plus sign, plus sign. OS. OS is going to be 20, 0. We have gotten OS in the previous question. And if you remember, go back and just perhaps just rewind the recording just a bit. You'll get what OS is, which is 20, 0. So what we're going to do is we're going to simply simplify this. Negative 16, negative 12 plus 20, 0. Negative 16 plus 20 will give me 4. Negative 12 plus 0 will give me negative 12. So that is going to be RS. Again, let's check it if it kind of making sense. If you're standing here, we're going to get an S. We're going to jump 1, 2, 3, 4, and come down 1, 2, 3, 4, etc., until we get to 12, right? It makes sense, right? So always check your position by putting yourself, well, not for CSEC, make sure you rub it up before you hand it up, right? But kind of lightly sketch it, very, very lightly. So if you're here and you need to get to there, that's a good idea to do. So this is the vector RS, right? It's 4, negative 12. Any questions there? Okay, great. Moving on. Now, this is state two geometrical relationships between PQ and RS. Where's PQ? PQ is 1, negative 3, which we have gotten before. And RS is 4, negative 12. This stuff we have gotten before as well. So you can go back previously into the question. We've gotten these two vectors before. So based on this, if you notice carefully, RS is 4 by 1, negative 3. Can you all see that? If I say 4 times 1, I will get 4. And if I say 4 times negative 3, I will get negative 12. So RS is equal to 4 times 1, negative 3. See if that makes sense to everybody. You guys awesome? Now, what is 1 negative 3? 1 negative 3 is PQ. So therefore, RS is equal to 4 my 1 negative 3, which is equal to 4 PQ. So based on this, what can we conclude about PQ and RS? RS is a scalar multiple of PQ, so RS is parallel to PQ. Right, that makes sense. And RS is 4 times the length of PQ. Does that make sense? Let's check it out. This is RS from here. RS is here. And PQ is here. Do you see? They do look parallel. Can you see that? RS and PQ are parallel. So if one vector is a multiple of another vector, those two vectors are parallel. And you can see here, PQ and RS are in fact parallel to each other. And it really does look like RS is 4 times the length of PQ. See if that makes sense, everybody. Hey guys, finished? Basically, that's going to be what it's all about. The geometrical relationships between the vectors. And it's clear to see exactly that they are parallel and one is 4 times the length of the other. Okay, so those are two geometrical relationships. So for example, if I had, supposing it was RS and SQ, in that case, because they will have a letter in common, RS and SQ, you can also say that they are collinear, which means they're on the same straight line. Okay, so those things come up, parallelism or parallel on the same straight line, and one is multiple times the other. All right, awesome, let's continue. So let's get to vectors and matrices. So given that W is equal to 3, 6, negative 2, 5, determine the 2 by 2 matrix L such that W plus L will give me 0, 0, 0. Well, clearly, it's going to be 3, 6, negative 2, 5 plus E, B, C, D is equal to 0, 0, 0, 0. So this is going to be W, this is going to be L. 3 plus E is equal to 0. Therefore, E, is going to be equal to negative 3. 3 plus negative 3 will give me 0. Clearly, 6 plus negative B will give me 0. Negative 2 plus 2 will give me 0. And 5 plus negative 5 will give me 0. In other words, this matrix is what I inputted. This is going to be matrix L. It has to be the additive. That's the word, right? The inverse additive of this matrix here. So 3 plus negative 3 will give me 0. 6 plus negative 6 will give me 0. Negative 2 plus 2 will give me 0. And 5 plus negative 5 will give me 0. And all those numbers that I just called are in this matrix here. So this has to be L. This is the 0 matrix. This is W. And L has to be this. Take a minute and see if it makes sense. Hey guys, so the word I was looking for is the additive inverse. A, B, C, and D, when you add it to 3, you will get 0 for each case, right? So this is the additive inverse, but that's not too important. Once you add the matrix, you get is negative 3, negative 6, 2, negative 5. Now, it says here, the 2 by 2 matrix P That's what we have to find, such that WP is equal to 1001. Recall that 3, 6, -2, 5 is equal to W. All we need to do is find the inverse of W. Why? Because this here is called the identity matrix. And any matrix multiplied by its inverse will give me the identity matrix. So learn this matrix, is a very famous matrix. This is called the identity. Let's get the proper color here. So it's going to be the identity matrix. 1001 is the identity matrix. And when any matrix is multiplied by its inverse, it gives you the identity matrix. Any questions there? Awesome. So let's find the inverse. That's the next logical step. So first we're going to find the det of W. The det is going to be 3 by 5 minus 6 by -2. I always advise that you should have a brackets here after the minus sign, and input it exactly as you see it into the calculator, and you will get the proper answer, right? Because the minus sign tends to make things complicated. So when you find the inverse, go ahead and put our brackets here. Similarly to the cosine rule. With the cosine rule, put our brackets over the other part of the rule where the negative sign is. After the negative sign, put everything after that in brackets. Minus signs make things complicated. Put it in the brackets and then put that exactly into the calculator and it will work out. All right, that's good advice. So next, see if it makes sense to you as well, right? Don't just take advice randomly. All right, next, this is the adjoint of the matrix W, which is how we do that. We're going to switch 3 and 5 up in positions, and we're going to switch the signs, the -2 and 6. So 6 becomes -6 and -2 becomes 2. Next, we're going to say the inverse of W is going to be 1 over the determinant multiplied by the adjoint, which gives me 1 over 27 multiplied by all of this, which gives me this answer here. So this is going to be the inverse of W, which is equal to P. Any questions there? Hey guys, awesome. All right, so let's continue. So finally, we come to this question, which involves matrices and transformations. So it says the matrix K maps the point S14 onto S prime -4, -1, and the point T35 onto T prime -5, -3. Given that K is equal to A, B, C, D, express a matrix as a matrix equation, the relationship between K, S, S prime, T, and T prime. Hence, determine the values of A, B, C, and D. Describe completely the geometric transformation, which is represented by the matrix K. So this is the first answer. So this is what happens is that you pre-multiply any transformation matrix. When I say pre-multiply, it goes on the left-hand side. Okay? It goes on the left-hand side and the points go on the right-hand side. Pre-multiply coming before. Reading from left to right, if you pre-multiply something, it comes on the left. Is that clear to everybody? What you all think? All right, awesome. So these are the points. These are the points S and T. How do I figure that? 1, 4, 1, 4. T 3, 5, 3, 5. And these here are the image of the points, S prime and T prime. -4, -1. So you have -4, -1 here. And T prime, -5, -3, -5, -3. So that's the matrix equation, pretty much straightforward. Now let's look at part 2, determine the values of A, B, C, and D. Well, what you have to do is find the inverse of the 1, 3, 4, 5 matrix. So the det of 1, 3, 4, 5 is 5 minus 12, which is -7. So the inverse is going to be 1 over -7 multiplied by 5, -3, -4, 1. And in this case, what you do is you put the inverse on the right-hand side, right? So which is a bit off from the usual. The usual is, what happens in the usual is this. X is equal to B. So X is equal to A inverse by B. But in this case, because the X or the unknown is on the left-hand side, right? It's like this, X, E is now equal to B. So to find what X is, you're going to say X is equal to B multiplied by A inverse. So the A inverse will be on the right-hand side of the B, where B is this. This matrix here is B. This matrix here is going to be X, and this matrix here is going to be A. Okay? Very important to remember. All right? Kind of unconventional, but very important to remember. And with that, we have the B, which is -4, -5, -1, -3, multiplied by the inverse of A, which is the inverse of this equation, this matrix here, sorry, which is this inverse here. And that will give me, when I multiply it out, row by column, row by column, row by column, and row by column, I will get 0, -1, -1, 0. So the question says, hence determine the values of A, B, C, and D. Well, A will be 0. B will be -1. C will be -1. And D will be 0. Any questions there? Here, everybody, great stuff. Let's look at number 3. It says describe completely the geometric transformation which is represented by the matrix K. Any matrix of that kind, K is equal to 0, -1, -1, 0, represents a reflecting in the line y equals -x. In other words, the K is a reflection transformation in the line y equals -x. And how do we know? That's one of the properties that is actually in the syllabus to learn, right? Of the matrix in the line y equals -x. Because if you check out S is 1, 4, and S prime is -4, -1. So the X and Y are reversed, and also their signs are reversed. That tells you that it is in the line, reflection is in the line Y is equal to -x. Okay? Any questions? So this part here is just a basic knowledge question. So this might be the key part of your profile. All right, so If I can just put it back, I'll put it back for a second, musing for a while, and then we continue. All right, great. So that's going to be our all the base topics coming for CSEC for paper 2. And sometimes you may have questions like this. Monty is cycling at 12 meters per second. After 4.5 seconds, he starts to decelerate. And after a further 2.5 seconds, he stops. The speed time graph is shown below. Calculate the constant deceleration. The deceleration starts from here, right? And it slopes to the left. So and also the gradient of a speed time graph is the acceleration or the deceleration, which means you have to look at this rise and run here. So it's going to be 12 from here to here is 12 over 2.5. The length from here to here is 2.5. So it's going to be negative 4.8 meters per second squared. Why is it negative? Because the line is sloping to the left. Any questions there? Right, awesome. And don't forget, the gradient of a speed time graph is the acceleration or deceleration. In this case, it's the deceleration because, well, they say it, and the line slopes to the left. If the line was sloping this way to the right, then it would have been an acceleration. But in this case, it's a deceleration. Let's move on. Calculate Monty's average speed over the 7 seconds. Well, speed is equal to distance over time. So we have to find the distance. What's the distance of a speed time graph? Is going to be the area under the speed time graph. The area under the speed time graph is the distance. So this is the speed time graph here. This is called this will be a trapezium, and to find the area of a trapezium is the same as when you find the area of a trapezium, you have to find the area of a trapezium in this context as well. And when we find that, we're going to find the distance. So the average distance is going to be area of the trapezium, which is 7 plus 4.5 over 2 by 12. Where did this 7 and 4.5 come from? It's the addition of the two parallel sides. From here to here is 7. From here to here is 4.5. We add them, divided by 2, and multiply by 12, where 12 is the perpendicular distance, or in this case, the speed from this way. So that's the average distance, and speed is distance over time. Don't forget, speed is going to be distance over time. Hence, the average speed is going to be the average distance divided by time, which is 69 divided by 7, which is 9.86 meters per second. Any questions there? Hey guys, awesome. All right, let's continue. So now we're going to look at paper 32. Paper 32, broad topics include measurement and geometry. Let's check it out. John makes a wooden barn to store grains for his farm animals. The barn is in the shape of a prism with a pentagonal cross-section and has dimensions as shown in the diagram below. This is the barn and in the shape of a pentagonal prism. So the question says, show that the outer surface of the barn, excluding the floor, is 2,034 meters squared. So first, let's look at the pentagonal prism, and check out the dimensions. Right, so you should think about it like this. It's like a barn, and the inner dimensions and workings of the house, well, the barn should kind of look like this. And now we're going to find the total surface area. So it's going to be 18 by 12 by 15, by 2 plus. So before we even get to there, let's identify the surface areas, which is going to be where? It's going to be here. This is a rectangle. It's going to be here. That's a rectangle. So this one in front here and the one in the back are going to be two rectangles. This one at the side here and the one inside there is going to be two rectangles. This rectangle has the slanted roof. The rectangle at the back for the slanted roof. So somewhere here. And then there's a triangle here at the front and a triangle at the back here, right? So they said excluding the floor. So it looks a bit noisy, but that helps you. Hope that helps you try to figure out, for us to figure out exactly where the surfaces are. And observing the dimensions, the total surface area, 18 by 15 by 2, is going to be this 18 by 15, but since there are two of them, we say by 2. All right, so this is the rectangle. The area of a rectangle is 18 by 15. And this 18 by 15 multiplied by 2, because we have two rectangles, that's what I have here. Next, adding, we're going to add 25 by 15. 25 is here, and 15 is here. By 2, because there's a rectangle in front here, and a rectangle on this other side here. And this half by 18 by 8 by 2 is the area of a triangle. So it's a half by 18, which is the base, by 8, which is the perpendicular height, by 2. The 2 signifies there are two triangles here and here. So far, so good. Any questions? Hey guys, let's continue. And then we have 12 by 25 by 2. What's 12 by 25 by 2? The 12 is this rectangle here, the sloping side of the roof. 12, and from here to here is going to be 25 because this is 25. And we have the area of one side is going to be 12 by 25, but there's two sloping sides, this side and this side of the back. So it's going to be 12 by 25 by 2. And you do get 2,304 meters squared. Go ahead and stop the recording for a second and verify that. Hey guys, you all done? Okay, great. Let's go on to the next part of the question. So the total surface area is going to be 2,034 meters squared shown. So it says here, given that 1 gallon of paint covers approximately 20 square meters of surface, determine the total amount of paint in liters that is needed to paint the outer surface of the barn. Given also that 1 gallon equals 3.79 liters. So this is a repeat in terms of this 1 gallon equals 3.79 liters. They have given a similar question to this already. Okay. Now we're going to find for 1 liter, not 1 gallon. Hence 3.79 liters is equal to 28 meters squared. In other words, 3.79 liters of paint can be used to cover 28 meters squared of surface. This implies that 20 meters squared is going to be equivalent to 3.79 liters. So 1 meter squared will need 3.79 over 28 liters of paint. That's what this means. Any questions? Hey guys. All right, so that makes sense pretty much. So 1 meter squared will be, we will need this amount of liters of paint. Now, to paint this surface area, it's going to be 2034 multiplied by 3.79 over 28, because this is the total surface area of the barn, excluding, of course, the floor. So 2034 multiplied by 3.79 over 28, which will give me 275.32 liters. So the total paint needed is going to be 275.32 liters. Okay, so we will require to show this per se, right? So 275.32 liters is sufficient. So a tip, even if you did not get the 2034 meters squared, you can still use it. Very important idea, right? So that 2034, even if you didn't get it in the previous question, you can still use it to figure out how much paint is needed. Right? So don't think it because they didn't get it, you can't use it. Yes, you can. All right, let's continue. If the paint is sold in 1 gallon containers only, how many containers of paint are needed to complete the job? Well, now 275.32 liters equals to 275.32 over 3.79 gallons, which is 72.648 gallons. But it only sells in 1 gallon container. So we divide the 275.32. We get this again, right? We have to get 73 containers. Okay, this we said 73 containers, not because we're gonna round this off, right? This wasn't rounded off. That's not a good idea to think about it like that. But it's better to think about it as we need 72 gallons and we need 0.6 of a gallon. But 0.6 of a gallon has to be in another container. So it's, and the hardware store, whoever they sell it by, doesn't sell paint in 0.6 or fractions of a gallon. They only sell it in whole 1 gallon, which is a discrete number. So you can only get, even if you wanted even if you had 72.1, 72.3, which is less than 5, you're still gonna need 73 containers. It's not a rounding off issue. It's a real world problem. That's what people free is. It's a real world problem. And if you have to get 0.3 of a gallon, anything above 72 gallons, you'll need a whole other container of paint. Okay? I hope that's crystal clear to everybody. Awesome. Let's continue. Right? And again, the answer is 73, not because 72.648 is approximately equal to 73. It's because the answer lies between 72 and 73. Yes. So once you cross 72, it automatically goes to 73. Suppose it was 73.5 or 73.6 or 73.2, then it's still over 73. You would have needed 74. All right. For example, if you have a maxi taxi carrying only 25 people, but you have 30 people, you can hire, you can get a fraction of a maxi to to pick up the 5 people. You have to get a whole other maxi, right? It's the exact same idea. Right, let's press on. So determine the capacity volume of the barn. The maximum volume is area by length. So the surface area is going to be 18 by, so right, we worked out the surface area already, right? So when we say area, we actually mean cross-sectional area, which is this here. This cross-sectional area multiplied by this length. Sorry about that. Multiply by this length, which is this length here. So what we're going to do is we're going to pick it out of here. What is the cross-sectional area? It's going to be the area of the triangle and the area of the rectangle. Which one? The 18 by 15 rectangle. So it's going to be this one and this one. That's going to be the cross-sectional area of the pentagonal barn. Do you all understand that? Please say Y in the chat if you understand. Please say N if you don't. Hey guys, awesome. So now that's going to be the area we're going to use. Take that area, which is 18 by 5 plus a half 18 by 8 and multiply by 25, which is going to be 8,550 cubic meters or meters cubed. Any questions there? Hey guys, don't forget you can stop the recording at any time and go back and check the answers. All right, so you can go back and check the answer with what you think at any point in time in the recording. Let's continue. So one of the things that are coming for paper 3 is algebra for everyday life. Algebra for everyday life is going to be linear algebra, right? That's what they actually mean. So let's look at this linear programming question again with Teacher Mabel. Teacher Mabel is providing a meal for all the junior students in her school. Each student will have either a hamburger or a pizza. The cost of a hamburger is $4, while the cost of a pizza is $5. Let X represent the number of hamburgers and Y the number of pizzas that she has, or that she buys rather. Fill in the missing equations inequalities in the table below to represent the condition given in column 2. So this is column 2 here. So we have to fill in this condition and make it consistent to what the condition is. So let's go. So each of the 220 students must get 1 meal. So this can translate to greater than or equal to 1. That's a fair deal as well. So the number of hamburgers plus the number of pizzas must be equal to 20 or greater than 20, greater than or equal to 20. So if they're X and Y respectively, then X plus Y is greater than or equal to 20. Any questions there? Hey guys, great. Next, Teacher Mabel has no more than $900 to cater for the meals for all the students, which means she can only spend up to $900. She can only spend up to $900. So what does that mean for us? If one hamburger is $4 and one pizza is $5, then if there are X amount of hamburgers and X amount and Y amount of pizzas, that means how much money is she going to spend on hamburgers? That's going to be 4X. How much money is she going to spend on pizzas? It's going to be 5 by Y or 5Y. And the money she spends in total must be less than or equal to $900. So 4X plus 5Y is equal to $900. Any questions there? Now with part C, it says she must buy more hamburgers than pizzas. So if hamburgers are X, pizzas are Y, X must be greater than Y. Okay, that's pretty much it for the conditions. What you think? Please put it in the comments. Hey guys, great. Let's continue. In this question here, it says the line corresponding to the inequality X is greater than Y is shown on the graph below. On the graph, draw the lines corresponding to the other inequalities, equations, inequalities in the table on page 6, which this is going to be the stuff we said before was the table on page 6, but this is the graph we have to draw it on. So the rules for linear algebra. First, you're going to write out all expressions down. X plus Y is greater than or equal to 20. For X plus 5Y is less than or equal to 900. X is greater than Y. Next, we're going to replace all inequality signs with equal signs. And finally, for all equations in 2 above, except the given one, X is equal to Y, we don't include that because that line has been drawn already. Okay? That's why we're not including it. But for every other equation, we're going to set X to 0, find Y, and plot it. So for this equation here, what we're going to do is equation 2a, we're going to let X equal 0. Therefore, 0 plus Y equals 220. Y equals 220, we're going to plot it. When X is 0, Y equals 220, plot it there. And now, we're going to set Y to 0, find X, and plot it. For the same equation 2a, Y is equal to 0. That means X plus 0 is equal to 220, and X is equal to 220. So when Y is 0, which is down here, X will be equal to 220. So we plot it. Next step, connect points. We're going to connect these 2 points here. All right, any questions there? Now we're going to do the same thing for part B. Let X equals to 0. Then if X is 0, then for equation 2b, if X is 0, then 4 by 0 will give me 0. 0 plus 5Y will give me 900. Hence, Y is equal to 900 over 5, which is 180. So we're going to plot that. When X is 0, Y is equal to 180, which is going to be here. Next, what we're going to do is we are going to set Y equals to 0. Before we had X equals to 0, now we're going to have Y equals to 0. So if Y is 0, 5 by 0 will give me 0. That's why I have 0 here. 4X plus 0 equals 900, meaning X is subject. So I have 225. So y is 0, which is here. So x is going to be 225, which is here. And then we connect the lines as before. Any questions there? Hey guys, let's continue. All right, so let's continue. Next, we know that's the line x plus y equals 20. And also that's the line 5x plus 5y, 4x plus 5y equals 900. So the question is, which region satisfies all inequalities? Which region satisfies all inequalities? So the region that satisfies all inequalities, let's first, it has to be greater than x plus y equals 220. Where's x plus y equals, right, it has to be greater than this. And it has to be less than 4x plus 5y equals 900. So 4x plus 5y is this line. So less than that is going to be below. And then x is greater than y. Where is x greater than y? Anywhere below here. Let's look at a random point, this point here. Right, at this point, x is 220 and y is 160. At any point below this line, x is greater than y. So where can we find a point where it's above this orange yellow line and below this line here at the same time? That only happens when these two lines cross at this point here. Okay, before we get to there, that only happens when these two lines cross at this point. Then we have a region above this line and below this line happening. A very, very small region. So we're going to take a closer look at this region here. This region here is going to be 220, 220, 220, 0, and 225, 0. In other words, this small region here is like a small triangle, where these are the vertices of the triangle. And when with linear algebra, we're going to look at the vertices of the triangle, of the shape, to determine the rest of the question, to help us with the rest of the question. Let's see what it says. It says use your graph to or otherwise determine the maximum number of hamburgers and pizzas that teacher Mabel can buy. Okay, so based on that, it has to be one of these. Now, if you simply add it, 220 plus 0, 225 plus 0, 220 plus 20, you may come up with this answer. All right, but in actuality, the maximum on the graph is actually 220, 200 and 220, which is this point. Not only that, it clearly says that she bought hamburgers and pizzas. So in all practicality, she would have hamburgers and pizzas. So if you choose this point here, you're saying she has no pizzas, which is unlikely in this scenario. All right. And additionally, if you solve this equation here, if you solve that equation using simultaneous equations, linear simultaneous equations, you will have x equal to 200 and y equals to 220. So in all probability, she would have bought both of each kind of food to eat. So it's reasonable to assume that the maximum number of hamburgers and pizza teacher Mabel can buy is 200 hamburgers and 20 pizzas. All right. Any questions there? Feel free to go back and re-listen to any part that you're not sure of. Let's press on. Right, and let's look at some problem topics that generally come for CSEC Math. So they include expressing this in the form e into x plus h all squared plus k. In other words, this is completing the square. So this is a very straightforward method for completing the square. First step, we identify a, b, and c. Next, that's going to be e is 3, b is -6, and c is equal to 1. Next, we're going to say h is equal to b over 2a, which is equal to -6 over 2 by 3, which is -1. And then we're going to say k is equal to c minus 0.5 bh. So we're going to replace c, b, and h with all the other, with 1, -6, and -1 as we had from before. Put it in this formula, and k is going to be -2. So we write on the values of a, h, and k like this. And at this point, we're simply going to replace a with 3, h is -1, and k is -2. So 3x squared minus 6x plus 1 is equal to 3 into x plus -1 all squared plus -2, which is equal to 3 into x minus 1 all squared minus 2. Any questions here? Awesome, right? So it's not necessarily the traditional way of completing the square, but you can check it out. You can use the other way, and it checks out every time. With this way. Again, these are the steps. And at the end of these steps, you get what e, h, and k will be substituted in this expression, and you will get the correct answer every time, right? So try with other quadratic expressions and tell me if it works. So let's talk about Bob. Bob only has $20 and he has a 9 p.m. curfew. He also has a $10 movie ticket. So he has $10. It takes him $10 to return from travel from the movies. And the start time of the movie is 7 p.m. And the duration is 1 hour and 50 minutes. Right, so let's chat about that for a second. So what is Bob's problem? He has some things he needs to get done, but he has a number of constraints. All right, the movie ticket is $10. He only has $20 and $10 return travel from where he is. He has a 9 p.m. curfew and the movie starts 7 p.m., but the duration is 1 hour and 50 minutes, which means the movie will finish at, or the runtime is 1 hour and 50 minutes, which means the movie is going to finish at 8:50, but he has a 9 p.m. curfew, so he has to return home, but he takes 40 minutes to return from the movies. So he has a number of constraints that he has to work under, and he's not sure what he's going to do. So Bob begins to think. He remembers that he has family that live within walking distance to the movie theater, and he can get a lift the next day with his uncle back home. His uncle passes Bob's house on the way to work every day. So he contacts them and he definitely asks them if he can stay over. And it's 5 minutes walk from the theater to the family's place. So he has some constraints, but he effectively made some adjustments and made the best possible solution or answer based on those limitations. He saves $10 and uses $5 from the $10 to buy snacks. Now Bob is enjoying the movie with very few little worries, right? He's no longer worrying about his curfew or his money. And all because of this idea, right? Linear programming. So that's what linear programming is all about. Getting the best possible solution based on certain constraints. So you can go ahead and take a screenshot or stop the recording and take some of this stuff down. It may very well help you. Awesome. So those are the some of the two troublesome questions that usually come for math. The linear programming is problematic, which we did already. I know this is like a synopsis of it, and the completing the square as well. Now, let's look at the paper one cool techniques. Actually, not a paper one, but let's look at a cool technique that you can do during, especially at paper two. Okay, so if you are asked to construct any diagram with rulers, rulers and compass, what you should do is this. Very cool hack. You should draw a sketch first of the drawing and put in all the angles and the sides that you need to. For example, like this, I'm putting all the angles, the size, and all the names. And then verify, double check, verify that everything in the question, you have everything in the question exactly as in the sketch, right? So double check, triple check, quadruple check. Make sure that everything in the question is exactly what you have in your sketch, nothing different. All right. Then what you could do is ignore the rest of the question completely and focus solely on the sketch. That way your concentration is not divided between the question and the sketch. Does everybody understand that? Does that make sense? So what you could do in any construction, make sure you read the question very carefully. Draw a sketch of that construction and make sure every single thing on your sketch is exactly what the question requires. Double check it, triple check it. Only when you are exceptionally sure, when you are 100% sure, then you can start constructing your sketch and ignore the question. Okay? But of course, when you're finished doing your sketch, it's advisable that you go ahead and check the question again to make sure your accurate drawing is what the question requires, right? So here I'm constructing a square. And it's exactly what is required. And all I do, I look at the sketch and use the sketch as what I need to do next. Okay? Any questions yet? If you think that makes sense, place a Y in the comments. And now, let's get into how we're going to pass CSEC Mathematics. Some techniques. So the first technique we need to be aware of is your time. Remember, paper one, multiple choice, 60 questions, 60 minutes. Paper two, structured 10 questions, 160 minutes. Paper 32 is algorithmic, 2 questions, 60 minutes. So do not spend more than 1 minute per question in paper 1. Do not spend more than 1 minute, right? In paper 2, do not spend more than 40 minutes. And in paper 3, do not spend more than 22 minutes per question in paper 3. Next, know your papers. What's coming in multiple choice, right? The whole syllabus is may come in multiple choice. And paper 2, each question is a topic, except the investigation question, which can be a combination of topics, a combination of ideas, right? In sequencing. In paper 32, can come from anywhere from the syllabus, algorithmic or recipe format. Each question is a blended topic. Very important. Know your papers. The technique, right? Know your tools. Multiple choice, no calculator use is allowed. All right. So remember, so don't go depending on the calculator. Calculator use is forbidden in paper 1. Paper 2, you can use a calculator, and paper 3, you can use a calculator. I recommend this calculator highly. There's lots of important functions that will help you to be successful. And these are some of the functions we have here. Know your tools. All of you should have a geometry set. Doesn't matter which brand, have a geometry set and ensure that geometry set is in good working order. Know your formulae, right? It's great if you can get to learn your formula between now and tomorrow. Well, nonetheless, make sure that you are aware it's there and ensure that when you get stuck during the exam, you can go back and look at it. Know your marks. Multiple choice, 30%. Paper 2, 50%. Paper 32, 20%. In the multiple choice, each question is 0.5%, which means every 2 questions is 1%. The other thing with multiple choice is do not leave out a single multiple choice question. Lots of people tend to leave it out. Never leave out a multiple choice question under 0 circumstances, because if you shade and you don't know the answer, you can accidentally shade the correct answer, and you never want to pass up on that chance. Paper 2, 0.5% is for each mark, whereas for paper 1, 0.5% of your overall mark would be per question. Paper 32, you have 10% for each question. This is the heaviest percentage-wise people, right? Each mark is 8%, because you have 2 questions and you have 10 marks each for each question. That's 20 marks, with 20 marks in total. So you're gonna have 1 mark is equal to 1% for people 32, unlike people 2, where 0.5% is 1 mark, and people 1, 0.5% per question. With that, we've come to the end of the broad topics revision. If you liked what you saw and heard, please don't forget to like and follow us on Instagrams at CML Online Maths. This is our number and this is our Facebook. All right, that's it, everybody. Have a good day, and please be successful in your exams and be safe. Thank you. Bye-bye.